Okay, exercise set 113.3, and we're going to start with problem number 1. Let me go to the whiteboard first off on that. I'll pull the whiteboard up. And, certainly reading it through, it says n is odd. Now, certainly, to be more clear about it, n is an odd integer, and it's greater than 1. So let me write this down for you. N is from this set of numbers. So it's an odd integer, greater than 1, so that's start at 3, and 5, 7, 9. All right? I'm going to make another slight abstraction over here. I'm going to say m is an integer. 1, 2, 3, 4, yada, yada, yada. All right? I'm going to say that n is the same thing as 2m plus 1. Now, I want to get my red pen out and show you what I mean by that. If m is 1, what would that produce? 2 plus 1, which is 3. If m is 2, I'd get 4 plus 1, which is 5. If m is 3, I'd get 6 plus 1 is 7. If m is 4, I'd get 8 plus 1, which is 9. All right, so that's, sort of a start to the problem. Now, what I want to claim over here is what they're saying that, and I'll write it down for you. They're saying that n minus 1 times n plus 1 is divisible by 24. That means there'll be no remainder. I'm going to write this a little bit differently. I'm going to write it as n times n minus 1 n plus 1. And you do maybe a little differently than that, n squared minus 1. So it's really the same meaning, that n times the quantity n squared minus 1 still loses by 24, they say. All right, so what I want to do is I want to kind of plug this m business in over here. So let's write this over here, n squared minus 1. Well, what's n? It's 2m plus 1. And what do we get now? I guess I'd have to square that, right? So it says n squared. What's that going to be? 4m squared plus 4m plus 1. That's n squared, by the way, minus 1. So I think I can further simplify that to 2m plus 1, 4m squared plus 4m. Okay, I'm going to factor that a little tiny bit. You're going to get 4m. Let's see, m plus 1. I just factored this guy. And then you're going to get 2m plus 1. I keep moving on this one and hoping it's going to lead somewhere, right? So let's write this down. 4m, m plus 1. And the 2m plus 1, I'm going to write it as m minus 1 plus m plus 2. Now, before I go forward, I want to make sure that that's correct. I do get 2m. Yeah, it's all right. So I'm going to, kind of talk about this guy and this guy separately now. And let's write this down. So you can get 4m, m plus 1, m minus 1, plus 4m, m plus 1, m plus 2. Okay. I'm going to rearrange this a tiny little bit. 4, m minus 1, m plus 1, plus 4, m plus 1, m plus 2. All right? So I think I'm getting closer to what I need. All right? And what I got over here is these are actually just 3 consecutive integers now. All right? And let's just take a look at that. And we're going to make sure they divide through by 24. So I'm starting to see something here, and I want to put down, I'm going to start to divide this by 24. So really what I need to show now, if I divide that by 24, 4 is 26 times, so I would have to have, it's m minus 1, m plus 1. And I need to show that that's divisible by 6, and I need to show that this is divisible by 6. All right? All right, so what do I know about that? There's 3 consecutive integers. Each of them, 3 consecutive integers. Now, by the way, 3 consecutive integers guaranteed to be divisible by 2. No doubt about it. Right. Why is that? Because you have 3 consecutive integers, it would be odd, or even, odd, even. Definitely divisible by 2. Is it divisible by 3, though? 3 consecutive integers. Divisible by 2 and divisible by 3. Let's take a look. Three consecutive integers. Let's just write this down. 1, 2, 3. Definitely divisible by 2 and 3. Let's do the next one. 2, 3, 4. Definitely divisible by 2 and 3. I think you get the idea what we're looking at. 3, 4, 5. Definitely divisible by 3, definitely divisible by 2. I want to point out there's a simple pattern happening over here. Let's put the next one. 4, 5, 6. You're always going to get a multiple of 3. You're always going to get a multiple of 3. You're always going to get a multiple of 3. All right? Always. Right? They're groups of 3s. And you're always going to get a multiple of 2. You get more than once, by the way, sometimes. So I'm going to say right now is we've shown this to be true. All right? So the bottom line is it's I'm not going to say that maybe the best strategy going through it. I want to go back to the answer key, though, and I want to just look at it, all right? So let's go back to the answer key, and let's see what they say. Yeah, a little more compact than I did it, all right? But I went through a lot of work, pre-work there. I also want to claim that, you know, certainly when I do something, you may say, I don't think it's the best way of doing it. It may not be. Certainly you also use modular arithmetic. That's not covered in the text, by the way. But there's other ways of doing it. So what I would recommend also is search the internet. Whoops, sorry about that. Internet. And I'm going to recommend YouTube. YouTube's a great place to see people working at the whiteboard problems that are similar to this. All right? Thank you.